Hello and welcome to a new episode about using FreeCAD for generating toolpaths for the CNC. In this episode I'm going to talk about making a rounded wooden box with a threaded lid. Even though it might sound pretty easy, it wasn't an easy thing to do because the threading function in the CAM workbench in FreeCAD is very useful for standard threads, but when going to custom threads it simply doesn't work. It does a mess about the outer and the inner radiuses. So what I had to do was to develop a macro that would make the toolpath, the spiral toolpath for making the threads. The macro is now able to make outer threads, inner threads, left hand, right hand, cutting them conventional or climb cut with certain tolerances. All you have to do is modify some dimensions in the macro header and then run the macro. It will generate the toolpath, and I will show you at the end of this video how to use it and the results on the CNC. Of course, you can download the macro for free on my Patreon account. It would mean a lot if you would subscribe, but the macro is available for free on my Patreon account. You can also buy a thanks or a big thanks, which is a one-time bonus if you're not ready to subscribe yet, and that would mean a lot to me. So let's get started. Let's first make the models on the screen for the threaded boxes, and then we will generate the toolpath. We will use the model to generate the pockets and the outlines and any other cut that is required before or after making the threads. In the part design workbench I will create two bodies. Let's rename them box and the second one will be lid. First of all, I'm going to work on the box, so right click and click on the active body. You can see it bold now, it's active. We are working on this body. The first thing I need to do is create a sketch on the XY plane, and then I will create a circle with the center in the origin and the total diameter. KO is the shortcut, the new shortcut in FreeCAD 0.22 for setting a diameter for a circle, so the diameter will be 80 millimeters. And I'm going to use a piece of wood of 35 millimeters high. But for now the pad for the box will be 45 millimeters. I will explain a little later why I have to do that. It's a problem with the Subtractive Helix. I don't know if it's a bug or not, but it simply doesn't work to cut the helix up to the top face of the body that we are cutting, so I'll have to make it bigger and then we'll slice a little bit of the top. So now in this box I'm going to make a hole in the center to fit certain little objects. Whatever reason you're making the box for, I will select this face, create a new sketch, and I will make a circle centered in the origin with a KO with a diameter of 50 millimeters and make a pocket of 35 millimeters. This will leave a bottom of 10 millimeters in the end. And now I want to make a recess outside on this edge, so I will select this face again, make a new sketch. I will create a circle with a radius of 70. I can also simply type here in the new version in the 0.22, so I will write 70 and make another circle larger because pocket will remove everything that is between the two circles. So now let's make a pocket also of 35 millimeters, leaving a bottom of 10 millimeters. This little ridge here is going to accommodate the lid, so when they close they fit perfectly. Now let's make the thread. For making the thread I need to create a new sketch, this time on the XZ plane. It's not going to be attached to any face. I'm going to use a straight cutter bit, not a cutter bit with an angle for threads because I don't have one. I will simply use a slitting saw type cutting bit. The profile of the thread will be a rectangle. I have drawn this rectangle. I will give it a height 3.17 millimeters, it's an eighth of an inch, and the length L is going to be 5 millimeters. That's how deep I want the cutter head to make the thread. All I have to do now is to set the position relative to the Z. Select this corner, press on L, and I will type 35 millimeters, which is half of the 70 diameter that this large circle has. So now let's position it on the vertical. Press I, press 0 to position it on the x-axis. Click on close. And you can see here the little sketch. I'm going to open the attachment offset position and I will change the Y to 15 millimeters. You can see that it moved upwards because this sketch is attached to the XZ plane. The XZ plane becomes XY and the Y axis becomes the Z axis. With the sketch selected, I will select this tool, the Subtractive Helix. and you can see a very nice helix here. I will simply leave the vertical sketch axis because the z-axis of the sketch is the same of the z-axis of the box. This way, rotating around the vertical sketch axis will rotate around the outer walls of the box. I want this thread to go all the way up. I will go to the height variable and increase it until it exits the material, maybe a little smaller. Also have to change the pitch. I want the pitch to be twice the height of the cutter. Because I was using a 3.17mm cutter, double that value is going to be 6.35mm. I will press OK. You can see everything is messed up. You can see almost nothing out of this helix. The first thing that I need to do is go back to the sketch, double click on it and change this dimension. Instead of 35, which is the radius of the wall that we are going to cut, I will write 35.01, just slightly outside of the body. This will avoid some conflicts. You can see now it is already better, but it still doesn't cut. This is the reason that even though I need a box of 35mm tall, I have created it with a height of 45. So I will go to the Subtractive Helix and I will reduce the height until it still remains a little bit in the material, but this little bit needs to be a little larger, so I'll write 28 here. 28 is still not enough, so I will double click again, reduce it to 27, and now the helix looks okay. I consider this a bug. The helix should be able to exit entirely out of the body, or at least barely touch it, but there's a random value when it's not going to be able to cut anymore. So that's why I've created the box taller. Let's get back to a 35mm tall box. Select this face, make a new sketch, make a circle larger than the entire box, and make a pocket of 10mm using it. And now the box is 35mm tall and the thread, as you can see, goes all the way out on the top. We now have the box ready. Let's move on to the lid. I will select the body, right click on it and select active body. Let's create a new sketch. Of course, in the XY plane it's easier to select it from here. Click on this button to hide everything up to the sketch and make another circle KO to give it a diameter of 80mm. Of course, I could have simply written it when creating the circle, but I'm not yet used to FreeCAD 0.22. And let's pad this sketch with a value of 35. I'm going to cut both of them out of the same piece of wood, so they have to be the same height. Rotate the lid, select the bottom face, create a new sketch, and I have to make a hole in the lid, which is going to be the inner diameter of the threaded part. I'm not sure what that was, so let's get back to the box, hide the lid and take a look at the drawing. So I want the hole to be this diameter. I don't know how to measure it because in 0.22 the measuring tools are kind of messed up. So the easiest way to find out the diameter of this circle is going to the sketch of the Subtractive Helix, selecting an informative constraint, select this corner, press on L, and you can see here I have a 30.01mm, so the diameter will be 60mm. I can now close this sketch, go back to the lid, to this sketch, select it, press KO to give it a diameter. Sorry, I forgot to switch back to driving constraints, so select the circle, press KO and give it a value of 60, which would be great if I have used a very stiff material, but wood isn't the best material for a threaded box, so let's modify it, write a 59.2mm. And with this sketch I'm going to make a pocket of 25mm. The next step is to create a thread in the lid. I could use the helix again, the Subtractive Helix, but the easiest way is to just make copies of these both items. So select the box, press on the little ship, create a clone, do the same with the lid. Before making the cut, I will create a second copy of the box because I'm going to change it again in the future. I will hide it for now, also hide the lid, also hide the box for now. So I will select the copy of the lid, I will hold Ctrl down and select the copy of the box, move to part workbench and make a cut. But it's not as it should have been because I forgot something very important. Let's just toggle this visible, and I have to move the copy of the lid upwards with 10mm, which is the bottom rim. And now if I hide them again, you can see the cut is a very nice matching piece for the box. What I still need to do is to make a little recess on this part. Let's move it back to the part design workbench, but I cannot make any modification on the cut, so I will need to make another copy. I will hide the cut again, and on this body I will select the top face because that's the only planar face up here. I cannot use this spiral face, so I will select the top face, select a new sketch and create a circle with a diameter of 70. You can see that after selecting the position of the center, when moving the mouse there's a field where I can enter the dimension, so 70 millimeters, and I will use this sketch to create a pocket of 10 millimeters. That should do it. Let's rename it the final lid. I still need to do the opposite of what I did for the lid with this little pocket. I need to make it also on the box. I need to make a little pocket on the top, because otherwise you can see the thread here is going to be very thin. Rename this copy final box, make it visible, right click on it, make it active body, select the top face, make a new sketch, and let's make a circle with a 59.5 diameter and another one which needs to be just larger than the entire box, and make a pocket of 5 millimeters. This will leave a margin for the two pieces to close perfectly tight at the bottom. So for the CNC part, we are in the CAM workbench, the former path workbench. I will select the final box and the final lid and select the new job button. Make sure they are both selected here in the solids. I will use a 6 millimeters template job, and now here I have to make a few settings for the stock, but for now I will just close the job because I have to first modify the position of the lid. They are placed exactly as I intersected them, so I will select the lid, go to edit, go to placement, check the apply incremental changes, rotate it twice with 90 degrees around the y-axis, change the Z, raise it with 45 millimeters. Also change the X to 140. This should leave me enough space, the large cutting bit for the thread going through here without any dangers. Click on apply and now double click on the job again. You can see the stock automatically updated. What didn't update is the position of the origin, so I will select this corner, go to the setup tab and click on the set origin button. This will be the 00 of my CNC. To the right plus X, to the bottom minus Y. I will also extend the X to the left with 35 millimeters and on both ends of Y with 10 millimeters. The 35 to the left will accommodate the cutter bit for the thread. It is a 31.5 millimeters in diameter cutting bit. I like to also toggle on the visibility of the stock, it helps me a lot, and I want up to an imaginary line between the two pieces. I want to remove all the material up to this face. I won't be able to use this job. I have tried to create an adaptive operation. It will take a lot of time. It will also cut this part, and when trying to apply a boundary dress up, the computer simply freezes. So the easiest way that I found to do this is select the final box again, create a new job using the same template. I will also extend the X35 on the left, but this time I will extend it to the right too with 35, the Y again with 10 millimeters. I want this box to be as close as possible to the one already created. Now go and select the corner, click on set origin. You can see it moved exactly on top of the other job. I will turn on the visibility of the stock, and in this second job, after selecting it, I will click on the adaptive operation, change the cut region to outside, change the step over to 85. I don't need a small step over because I don't need nice finish. I just want a lot of material removed. Check the depth, make sure it goes up to this face. You can see now it's 35 millimeters. I will select this line, click on the arrow next to final depth. Now it will go down to 10 millimeters. Go to the geometry. I want this face, select it, click on add, and this face I want them to be left just as they are. I don't want them to be cut. Uncheck the finishing profile and then I will click apply. Wait a little time. You can see it generates the toolpath for one layer and then it will generate all the layers. What I still need to cut is this face here. Hide the adaptive, press space to hide the adaptive for now. Select this bottom line here, click on the profile, make sure the depth are okay, so it's 35 with a final depth of 10 millimeters. Go to the operation, cut side, change it to outside. I want to cut the outside of this circle. Click on apply, you can see the path generated. I can turn the visibility of the adaptive again on. This job alone, I will export it all by itself because I want to remove all the material on the outside of the final box. I will then cut the inside of the lid, then cut the outside thread and the inside thread, and in the end I will make all the finishing touches. But for now I want to leave as much material as possible, so I will select the job, click on post process, click on OK, select a file name, wooden box threaded lid part 1. I will turn off its visibility, also the visibility of the operations, the model and the stock. Then move back to the initial job, turn back the visibility of both objects. And now we need to mill the inside of this hole. So I will select this face and this little face that remained. Holding Ctrl and selecting it won't show up in the view, but they are selected, and I will use the pocket shape tool. Change the pattern from zigzag. I usually used offset because I liked it a lot better. It leaves a much smoother finish. On the zigzag you can see here a lot of portions that aren't going to be milled, but offset usually leaves a lot of overlapping lines, even though I have a 100% step over. So I have discovered that zigzag offset is much better at clearing, also leaving a smooth finish. Using an angle of 0 makes all these parallel cuts only on the x-axis, which is the most stable axis on my CNC, so I like to use these settings when making pockets. Also change the step over to slightly smaller than 100 to make sure the lines are overlapping. I will click OK because that's all I need to do about this pocket, but I also need to make this profiling here on the top, so I will select this line. Make sure you select the circle and not the line that is very close to this one. Click on the profile operation. Now leave it to inside because I want it to be cut on the inside. Click on apply and it will also make this cut. Now let's export this job too. Click on this button, post process the job, click on OK, go to the folder and save it as part 2. I have the clearing of the outside of the box and the inside of the lid. So now we need to make the threads. For these threads, don't forget to go to my Patreon page. You can download from there the macro for free. Of course you can subscribe, you will get a lot of other files. If you subscribe also, it will help me a lot. If you don't want to subscribe yet, you can buy a big thanks, a one-time big thanks or a one-time thanks. So thank you in advance. And after downloading the macro, you have to go to the macro menu, go to the macros. Here you can see user macros location. Copy the threads macro that you have downloaded, copy it to this folder. Select the threads macro and click on edit. We need to edit it because we need to modify all these variables which will determine the thread type that is going to be created. The first two values are the X position and the Y position. As you remember, the origin of the box and of the lid were in the center, so the center of the thread will be exactly the center of this box. I can see in the placement it's 74.84 and minus 49.96, so the X is 74.84. Go back to the macro and change the X position 74.84, and for the Y position you can see here it's minus 49.96. So write it here at Y position. The next two values are the major diameter and the minor diameter of the thread. The major diameter is the outer diameter of the thread and the minor diameter is the one on the inside. As you remember, the outer one was 70 millimeters and the thread profile was 5 millimeters. So we will have a major diameter of 70 and a minor diameter of 65. The cutter diameter, of course, depends on your cutter. My cutter is 31.5 millimeters. I write these dimensions here. You have to remember that all the dimensions are in millimeters. I also have a field horizontal tolerance, but I will explain it a little bit later. Let's move on to the passes. It's the number of passes it will make on the horizontal, the step over. I want 3 passes to avoid cutting too much material at one time. Let's now set up the start position, which is 35, and the thread depth, the distance that it's going to go from the start position, the start Z, which is here. How do I find that out? I will select this line and look here in the Python console, it has a Z of 15. You have to remember that all the Z values of this macro, all the thread depth, the Z star, the Z safe, are the bottom corner of the toolbit. So if I'm starting at 35 millimeters and I want to reach 15 millimeters, I will have a thread depth of 20 millimeters. After creating the first thread, I will explain what both horizontal and vertical tolerance do. The Z safe, of course, is the height at which the cutter head moves when it doesn't cut. The lid diameter is the diameter of the circle described when the cutter head moves towards the material. I will also be able to explain it a little bit better when the first thread is created. The feed rate, of course, is the speed at which the machine will move, and I have three more variables. The direction, which is 0 for a right hand thread, I can change it to 1, it will result in a left hand thread. The cut type, 0 by default, climb cut. If I change it to 1, I will have a conventional cut, and the position, which is 1, it's an internal thread. I was working on the box, not on the lid, so I want an outer thread. Change the position value to 0. Now that all the fields are set, I will hold Ctrl and press F6 or macro, execute macro. You can see here the shortcut Ctrl F6. The macro has been executed, and you can see here there's a path thread external right hand climb. Let's switch back to the view. Now I can explain a little better the lid diameter, which is 12 millimeters. It's the diameter of this circle here, which is a round, a smooth leading, so it doesn't just simply go into the material. The number of rotations depends on the total height of the thread. What you need to take into account that it will always start here. I've told you that I will explain what the other two values that are present in the macro do. The horizontal tolerance, let's make it a 1, and after making it 1, run the macro again, execute the macro again. You can see I now have two operations, external right hand climb and external right hand climb 001. You can easily see by hovering the operation that this operation is moved to the inside with 1 millimeter, which means the thread cutout will be 1 millimeter towards the inside. We also have vertical tolerance, which is 0. Let's also switch this to 1 and execute the macro again. Let's go back to the 3D view. You can see I have two passes on the Z-axis. The vertical tolerance will make another cut slightly higher than the initial cut. This will result in wider channels here for the thread to fit a little bit easier. Adding these tolerances might help a lot matching the pieces at the end. You have to take into account that after creating a new operation, you have to delete the previous one. This macro won't delete the one before. I will leave these tolerances of 1 millimeter. On the vertical I will write a 0.5 because the 0.5 for the outer and the 0.5 for the inner will result in a total tolerance of 1 millimeter. One final run of the macro, delete the previous, and this is the final path for the thread. Let's do the same for the lid. First of all, I will deactivate these two operations. I have already exported them. Select the lid, and here I have the placement, the X and Y. Go back to the macro, change the X to 214.84, the minus 49.96. I will leave it as is, leave the same diameters and the same tolerance, but I need to change the position. This time I want an internal thread. Press Ctrl F6 or go to macro, execute macro, and here you can see thread internal right hand climb. Let's go back to the 3D view. You can see that this time the leading, of course, is from the inside. We have the same tolerance. You can make some tests depending on the material, depending on the machine. You might want to adjust these values. So now that I have these two operations ready, you can see them. They are not contained in any job. I will select them both and drag them to the operations in the first job. It doesn't matter what job I drag them, just make sure you have the correct origin and it will work. Now go to the job, click on post process. You won't find any M3, any command to start the spindle, so you'll have to edit manually because the script doesn't take into account the settings of the job. So type M3S, which is the spindle speed. I will use a 14,500 spindle speed. Click on OK, save it as part 3, and for this part I will also write threads. So when I open the file, I know I have to change the cutter head and adjust the Z, of course, reset it after changing the cutter head. I can move them out now. I will drag them to the root of the document. so I can still have them here, but they won't be exported when exporting the job. Another thing about these two operations is that they cannot be turned on, activated or deactivated using this button, because they are not operations in the CAM workbench idea. They are just simple G codes, so I cannot make a lot of things with them. I'm planning on building a custom workbench which will have some additional tools, and that will be able to create this kind of operations to have all the features that the other operations in the CAM workbench do. So now, after cutting the threads, we still have to cut the outside of the two parts and the inside for the box. Go back to the first job, select the bottom of this hole, click on the pocket operation, go to zigzag offset, change the angle to 0 or whatever suits your needs. A step over of 85 should do it. Click on apply, make sure the path is correct. So I need to cut the outside of the box. I will select the bottom circle, click on the profile operation, make sure the cut side is set on the outside, click on apply. You can see it starts at the top of the stock. I don't want that because all this area around here is already cleared, so I will zoom in, select the line on the edge of this face and click on the arrow next to start depth. Click on apply again and it will only cut the remaining part. I will select the operation, go to CAM, path dress up and select tag. Here you can see that FreeCAD automatically created 4 tags. I will delete 2 of them, it doesn't matter which ones. Just select them from the list and click on delete. And for the other 2, select the first one, click on edit, place them wherever they're convenient. I will place them on some sort of horizontal line here. Now select the second one, click on edit, select the point. I will also change the height to 8 millimeters to have enough material to hold the piece down. Angle to 90, which will result in some straight tabs. They are strong enough to hold the wood into place. So after milling everything, I will cut them using the benzo and just make a little sanding. So now that I have all the operations for the box, let's make the same thing for the lid. Export this job too using the post-process button. And now let's move to the CNC. You can make almost any type of round box using this file that you can find on my Patreon page, and of course this threads macro, which you can download for free on my Patreon page. But subscribing would be very helpful to me, and if you don't feel like subscribing yet, of course you can buy a thanks, a $3 thanks, or a big thanks, a $10 big thanks. This helps me a lot to keep up what I'm doing, to discover new things, and of course to build a lot of useful tools such as this threads macro. Thank you for watching and see you next time.